This is week 11, day 20. Monday, 11/5/18. Yeah, both Tuesday. So, introduction to networks. IP4 addressing, questions, IP6 addressing, we just talked a little bit about that. We also did subnetting. We did some subnetting with addresses. And I talked a little bit about, we talked about multi-layered switch, and you can have all of these separate networks connected to a multi-layered switch. You can use access list to literally control how content can move through the device. And then I talked about connecting out to a router, and then this router has 3 different networks. We talked a little bit about the fact that an ARP sends out a broadcast, and then you can narrow your broadcast because there's a broadcast domain, there's a broadcast domain, there's a broadcast domain, because a router won't forward broadcast. It's the same way here. You know, on any one of these, you can have a switch, you know, with maybe, I don't know, 10, 50, 100 workstations, but the broadcast domain then would be narrowed to just this area, however many devices you have on there. Alright, so let's do a little review. Up here, I draw this all the time. You know, here's the values in decimal for positions in terms of bits. So in this case we got one group of 64, I'm looking right here, one group of 32, and we got a group of 8 here, and a group of 4 here, and a group of 1 here. Add that up, you get 109. Let's take a look at the other example. We got one group of 8 and one group of 2. So that would be 10. Okay. Over here we actually worked it in reverse. We took this 10 and we figured out which bits would be in there. You get how that works? So let's just do another one. Just right here, let's say I had the number 30, and we wanted to change that to binary. So we have 0 groups of 128, 0 groups of 64, 0 groups of 32, 1 group of 16. Get it? I'm going to subtract it. 14. So then we got one group of 8. And it was 6, one group of 4, and one group of 2. So that's equivalent to 30. Up here, if we go back up here and we look at this, we have that /16. This is the network, this is the host. And then later on we'll talk about this can also be referred to as the interface when we talk about IP6. And then in this situation I showed when you AND them, here's the mask, right? 16 prefix bits, and so when you AND it, that gets to be a 1 there, and then a 1 there, And what you'll see is ANDing creates then just the network. Talk more about that later on. Okay, so let's look at some examples here. Here we have an address, /24, so this part of the address we can't change. Okay, so this part I wrote out as a group of bits. And then if we borrowed 3 bits, 1, 2, 3, if we borrow 3 bits, we can draw a line here. And this would give us 8 combinations. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. Have I got them all? 0, 0, 0, 0, 1, 0, 1, 0. 0, 1, 1, yep. And then you could keep going. There would be 8 of them. So this, if we make this the new network, okay, make that the new network, we would have 8 more networks we can make. And then this part would be the host. 1, 2, 3, 4, 5. So that would be 2 to the 3rd. So that, or excuse me, 2 to the 5th, which would be 32. Take 2 off, 1 for the broadcast and 1 for the network. So that would give us 30 hosts per network. It was a /24, and I borrowed 3 bits. That's why it becomes a /27. So this first one, let me see if I can do this. This first one here, you see that? /27. It's all zeros. And then a 1 here, this position up here, like if you looked up here, be 32, so that one would be 32, and then they'll go up by 32 each time, each of the networks. And you could list all 8 of them if you wanted to. So it's subnetting. You decide how many bits you're going to move over to the network side and what do you have left for the host. Or in some cases you might look at how many hosts you need and then just pick that and then move everything else over to the network. Let's look at another. Here's a number at 9. So this is our public address. Sometimes that's referred to also as a global address. It's an address we can use out on the internet. So let's take a look at this one. So I said if we're going to borrow 2 bits, this would give us, these 2 bits would give us these combinations. So it gives us 4 new networks we can use. So the first one would be 0, 207.165.226, 0 /26. It was 24. And then we added these 2, 24, 25, 26. So this is the network part. And these are the host part. Okay? And there's how many bits there? 1, 2, 3, 4, 5, 6. 2 to the 6 is 64. Minus 2, so that'll give us 60 addresses. So here's the first one. That's 0. Then here are the addresses. 207.165.226, 1, 2, 207.165.226, 62. Here's the next one. 64 is the network. 65 is our first usable address. 126 would be our last one. 127 would be the broadcast. 128 is the next network. Okay? So these are the options for those bits. And these are the range of addresses we can use. What a router does then, it does this ANDing. So it gets an address /16, then it ANDs it with the mask. In this case it would be, this mask would be 255.255.0.0. And when it ANDs it, it ends up with the network address. That would be a 10. This is referred to here as the host. Later on we will call it also the interface. Okay. So we talked about, for example, we have this public address that we can use over here in the academic IT. And then some of these same addresses, we don't have all of them, some of those same addresses are being used in the main campus, and this router then, when traffic comes in, can decide which way the traffic goes based on the addresses. So you can be at home, you can use this address to come in, and when the router sees it, it's going to send it over this way. And it actually, in here, gets, let me see here, let me do this, actually uses NAT to translate it to the internal address for the same thing. Which you know, right? We know that. This internal address is 172.21.0.85. These two are mapped to each other. Inside NAT, so down here is example. This is the address NIAC has. We can have this many hosts /24, and this is the range we have. This part's the network, host, or in some cases would be called the interface. And that's it.